Forest residues. What are they? Are they actually waste? Or can they be used as potential energy source that can replace fossil fuels for electricity, heat, or oil? When a log is being processed by the sawmill, making it into boards, 60% of that log are considered to be waste, like chips, hog fuels, barks. And what do they do with all those waste? They either burn them or use them as landfill. However, if we use that waste as a renewable energy source, not only we can reduce the damage to the environment, at the same time, the industry will make more money. So you must be wondering, why aren't we using that as our new energy source? Turns out, the biggest challenge of all is the cost. The high cost from its own supply chain is one of the biggest problems that we're not using this as our new energy source. These challenges include capital investment, feedstock availability, and quality and cost. Therefore, a linear programming model is developed to maximize the net present value for using forest residues as a new energy source. This includes determining the locations that and the type and the size of technology used, the mix of biofuel and bioenergy products to generate, and also the type and amount of forest residue used. Also talk about the transportation strategy that minimize the transportation costs from the sources to the facility and from facility to the market. Source to use or the level of some activity. In our case, the decision variables are the amount of biomass that is being transported in a given time. The first step in developing a linear program is to determine what are the decision variables. Typically, the variables represent the amount of a resource or the amount of bioproduct being produced at this location during a given time. The objective function in this case is to maximize the net present value, which is presented by the total revenue minus the total cost times the depreciation rate of 5% over the time span of 20 years. The total revenue is calculated by the sum of biofuel price times the amount of biofuel product produced, plus the sum of bioenergy price times the amount of bioenergy product produced. The total cost is the sum of biomass cost plus the transportation cost of the biomass and the fixed cost, which is the technology, plus the variable cost plus biofuel transportation cost to the market. The third part of developing a linear program is to provide constraints. The constraints restrict a certain limit to variables. For example, in our case, the constraint restricts the amount of each biomass type that can be purchased from each source, or the amount of bioproduct that can be produced cannot exceed decision variables capacity, or a set of variables that need to be determined in order to solve the problem. For example, the problem will be solved when the best values of the variables has been identified. The variables are sometimes called decision variables because the problem is to decide what value each variable should take.